Around us can often seem random, whether it's coin flips or airplane turbulence, lightning strikes. And so much of the work of science for so long has been to try and peer past this layer of randomness, trying to understand why nature behaves the way it does underneath. But my interest is in why there's a barrier of randomness at all. How does randomness and chaos emerge from the simplest of systems? To tackle this problem, I tried to look to the smallest scales possible, one atom at a time. In my research, I used a combination of vacuums, lasers, and magnetic fields to create an environment which is almost completely decoupled from the outside world. And into that environment, I inject just 100 single atoms. I can move those atoms around programmatically as if they were little atomic Lego bricks, and I can use them to form complex structures like the Caltech logo, spelled with only 80 atoms. And these atoms really form their own little universe where we can completely turn off the noise of the outside world. And the question I want to ask is essentially, is randomness intrinsic even to this most pristine of systems, or is it just some artifact of interactions with the outside? So to study this, I play a game of atomic telephone. I set the atoms up in a chain, and then I shine ultraviolet light on them. That makes the atoms get excited, makes them start talking to each other. And they start with their nearest neighbors and send information down the chain. And then I look at the end of the game and I see how information has developed, and I see a complex structure emerge where all the atoms form one collective state. But something changes if now the interaction with the environment starts changing over time. For instance, if the power of the ultraviolet laser starts fluctuating. In that case, that complex order breaks, and the message that we want to read out from the atoms at the end of the game, it becomes garbled and unrecoverable. Essentially, what my research so far has shown is that even the most pristine systems have a tendency towards highly fragile states, which are highly susceptible to small perturbations, causing chaotic outcomes. But with our 100 atoms, we're able to study this process and turn up and down the noise so that we can understand the same transition from order to chaos in our outside world. And now that we understand how randomness can emerge, and how it can corrupt our game of telephone, we're able to build around it. And so we can construct our atoms into different types of structures that are impervious to different types of noise sources. And by doing that, we're able to study a whole host of science, ranging from fundamental physics to materials chemistry or applied chromatography. And so we're really trying to enter a new paradigm in how we interact with the world around us. We're no longer just constrained to observe nature. Instead, using our type of atomic telephone, we can build nature ourselves, one atom at a time. Thank you.